Hey there, Be the Calculator here, and this looks like a fun problem. We have a set of 5 interlocking grids. Can you spot the patterns between them to figure out the missing number highlighted in red? If you'd like a challenge, pause me here and get cracking with a solution. If you'd like to know the 4 multiple choice options, keep watching for another 10 seconds. Option A is 45, option B is 30, option C is 52, and option D is 18. If you haven't already, pause me here and get cracking with a solution. An animated solution will be coming up in 3, 2, 1. To start off, we can see the main square in the middle links together the 4 other grids. So this square must have something to do with the outer numbers on the sides of each of the separate grids. That is, the outer numbers must be linked in some way to the one number that links the center square to the outer square. So 7, 4 and 3 must link in some way to 14. 9, 2 and 6 must link in some way to 18. 12, 2 and 4 to 16, and of course 9, 5 and 4 to our missing number in red. As it's a pattern, this link must be the same or similar across all of these numbers. So we can get rid of the grid at this point and simplify our solution onto these 4 separate numbers. 14, 18, 16 and our missing number. Well, to start off, 7, 4 and 3, intuitively we can see to add together these 3 numbers. 7, 4 and 3 gives 14. So if we try and prove that logic to the next one on the line, 9, 2 and 6, we can see if we have a pattern or we should move on to another solution. So 9 plus 2 plus 6 is 17, which is not 18. So this addition of the 3 numbers isn't our pattern. But what we can see from this is 7 links with 14 by multiplication. 7 times 2 is 14. So let's try multiplying our 7, 4 and 3 together and see how we can get to 14 from there. So 7 multiplied by 4 multiplied by 3 gives 84. To get to 14 we need to divide by 6. So this works as a standalone solution. Let's put that down in the corner and see if we can replicate that for the second one in the line. Multiplying all of 9, 2 and 6 together gives 108. Dividing by 6 gives 18, exactly what we want. And we can see here we needn't do the entire multiplication anyway. 6 and 6 on the bottom cancel nicely, giving 9 times 2 as the only numerator, which is 18. Let's apply this to the third one to see if we're lucky for the third time and we have a pattern for all 4. 12 times 2 times 4, and we can cancel 12 on the top with 6 on the denominator, giving 2 on the top. 2 times 2 times 4 is 16 as needed. We're good to go with this pattern for the final 9, 5 and 4 to get our missing number. Multiply all of them together and divide by 6. When we multiply them all together, we can go ahead and do this on the top to get our numerator and then divide again by 6 to get our answer. But we could also split 6 into its prime factors of 3 and 2. And we can cancel, like we have before, the 9 on the top with 3 on the denominator, giving 3 on the numerator. We can also divide 4 by 2, giving 2 on the numerator, leaving us with 3 multiplied by 5 multiplied by 2. And this gives 30. Option B, 30, is our final answer, the missing number in this number grid. This interlocking system was used by first finding the links between the 3 numbers to our central number, and then verifying this works for all 3 numbers before applying this to the final 4th grid. We hope you enjoyed solving this one, and thanks for watching Beat the Calculator. See you next time for more logic and maths fun.